Hey, good morning, everyone. So I think we can get started with today's code words. Uh, so I am Piyush Kataria. I am acting as a technical architect in Red Panda, um, and we will be discussing today about the expression problem. So expression, how many of us have heard of the expression problem? Have you heard of it before? Okay. Uh, anyone who joined us online? Has anyone heard of expression problem before? Hello. Well, you can talk instead of commenting. That would be fine. Otherwise, I have to, click each and every time. Okay. Uh, so, expression problem is the kind of word which is coined by Philip Wadler. Uh, so, as he states it, it's basically a problem with which arises when you have when you want to add a new data type or a new kind of operation in the software while modeling the problem statement in the software system. Okay, so what he observed that most of the widely accepted statically typed languages do not support the extension of data type and extension of methods at the same time. Okay, so there is these are like orthogonal to each other. Okay, sorry, did not understand. uh, okay. Yeah, so let's talk more about the object-oriented programming, O kind of style and functional kind of style. So in object-oriented languages, you have fixed set of operations. I mean the natural modeling intent of it. Okay, and you go on creating new classes by inheriting them, by composing them, whatever it is, to make use of the existing operations. So it's easier in object-oriented programming to come up with the new types. Okay, but when you have to come up with the new operation, you cannot do that by not modifying the existing code. In functional languages, you have fixed set of things, totally the opposite thing. But uh, so as it mentioned here, as the code evolves, you have many number of operations. Okay, so functional programming languages are good when there are very less number of set of things and more operations. Object oriented programming is like more things and less operations and more common operations. Okay, so yes, so we're gonna have the whole uh, tutorial for it, the actual hands-on tutorial, but I'm just going through. So for example, this is the type and this is the operation, the constant, add, negate, and these are the methods. Okay, print, evaluate. Okay, so what they say is in OOP, when you add a new operation, you have to touch the existing code, modify the existing code. Okay, and but when it comes to define a new type, so the first column is the type and that header row is the operation. Okay, so on top of that, if I suppose add a new type like subtract, then it would be a cool. in terms of functional programming, the exact is true. Sorry, the reverse is true. You can add new operation, but you can have, it will be a problem to add a new type. Okay. Okay. This was just to give you background. I'm not finishing with this. So this is the main problem, just in case if you missed it. So the goal is to define a data type and the operations without compiling the existing code. Can you add that? The operation on additional data type and additional this thing. Okay. Okay. So let's jump to. So let's start with Java. So by the way, I'll be exploring this solution of this expression problem through Java and Haskell, but this session is by no means is an introduction to Java or introduction to Haskell. We are just focusing on you know, the only part of the Java and only part of the Haskell which contribute to which is enough to explore this problem and make a point that about the software extension. So I'll not be covering all the features of Java 8 and all the features of Haskell. That would be the out of scope for this session. How many of us already know Java here? You know Java, okay. Not Haskell? Okay. Okay, so let's start with the expression. So let's solve this. So we have a constant add and this operator, right? Constant add and negate and then print and evaluate, right? So this is the thing. So I have defined a simple expression, a constant and an add. So I am modeling, what am I modeling? The whole expression, world, like how the expressions are, what are the different operations like add, subtract and all. So if I model into OOP, I would have a constant. Instead of just having an integer, I have a constant, a container around it. Okay, and so these are different kinds of expression. Constant is also an expression, add is an expression. Okay, now, so this code is not helpful by itself. Okay, so we have to add something. So suppose, what if I add some print method? Okay, I like to print the expression, right? So what should I? Okay, so what I did just do, added more operation. Okay, yes, that's not okay. So new operation causes the existing code to change, right? Okay, so how do we implement that? Right. So what you're gonna write here? Info, whatever, toString. And maybe, sorry. I like to implement the method and maybe return. So this is the add operation, right? So right. So plus is addition of left dot toString. Because we have implemented toString for everything and we are passing the expression, so we can assume that the expression have a meaningful toString, or maybe we can say print this value and sorry. Okay, so addition of new operation causes the code to change, right? Now what if I like to add new data type? Okay, what I like to do is implement the negate. Okay, What is the negation of, negation is also expression, right? Or subtraction, any of these things. Okay, so when I add a negate, I don't have to touch the existing code. Okay, so even if it sits in the different altogether different jar file, which I don't have access to, I can manage, right? Excuse me. So similarly, um, we can get final uh, a constant, a constant or an integer. Don't matter. Yeah. Okay. So we have seen that what this came from. So if I add the operation, I have to again, change all the code. If I add a new type, it's fine. Now print is, it's okay, but what if I like to evaluate it? Evaluate actually the expression. Printing is fine, right? What if I like to evaluate? Again, so I have to add a new operation. Okay? Evaluate. Okay, now I have to change the whole existing process, right? Okay, so what is the evaluation of it? Oh, oops, sorry. It could be integer. And we can just pass it down, right? And implement the methods. How do I evaluate this? Left dot evaluate plus. Okay. How about this? And minus. Right? Okay. So let's try to run this. Just a minute. So if we go here, and if we already have. Okay, so what am I doing here? I'm adding the thing. So 1 is the constant, 2, and another one is the negation of the constant. Okay, and I'm just saying add dot evaluate. Okay. Oops. We haven't gone here. -2. Yeah. Okay. So that is how. So what we build is the expression language here. Add constant, and the way we modeled it is each and every this thing is modeled as a class. So far so good. Uh, any questions from online guys? Okay, so now let's look at the other problem. This is Haskell. Okay, we may not have. Okay, just focus on the uncommented code here. Okay, guys, can you mute? Okay, so now I'll give you very simple introduction to Haskell about how the data types are and how is it. So I think at least we must have heard of Haskell. Okay, so it's a purely functional programming language. It does not preserve the state. It is totally against the state. So for example, in our program, we are preserving the state like integer inside the expression. We accept it to the constructor, and so Haskell is about all about purity, whether it's a referential transparency, whether it's clear demarcation between pure and impure code by wrapping the impure code into the monads. Monad is just another container for simplicity purpose, I'm saying. Okay. If you look at the actual mathematical definition of monad, it's just not incomprehensible. So just say that it's some kind of container uh, which kind of encapsulates the impure code. Okay. Now, so look at this. So this is called as abstract data types. Okay, ADT, Haskell ADTs. What I'm defining here is define a type expression which could be of type constant and which will take one int value. So if you compare with the constant Java, like a constructor here, is closely related to constructor. But it's a pure type, it doesn't have any operation. You cannot say like, expression dot something else. So data is different, whole operations are different. OOP is like combining them together in a single class. Haskell is about data is different, operations are different. Just keep them separate. Okay, so so we have one here, just a minute, one, and if I like to say pretty print it. Okay. Okay, so just like we have a JVM, and the whole of the compiler and JDK and JRE, in Haskell we have GHC, Glasgow Haskell compiler, and we can make use of some of its REPL functionalities to load it. So unlike Java, you can load the whole file, or for that matter, the whole project into the REPL, fiddle with it, load it again. Okay, so from REPL driven development, it is very pleasure to work with Haskell projects. Okay, so I'll just go into the CNC directory and try to load expr. So expr.hs, hs is the extension, just like .java is Haskell. Okay, so if I try to load, it will compile and say it's loaded. Okay, now look at this thing. What we did, we defined an expression type for simplicity purpose to just to get started. Suppose this is the interface or the base class, and this is like child class, but we are only talking about data here. Okay, the relationship is only due to the data, not the operations. Okay, and I am defining whole different method. So this is the syntax. Okay, so this syntax says it takes the argument which is of type expression, and the last one it returns the string. Okay, so this is the declaration. Sorry, so this is the declaration of the pretty print method. Okay, and this is the definition for type constant. So this is called as pattern matching. So expression could be could be anything, but this code will execute only if it matches or if it is of type constant. And in this pattern matching, not I'm not only you know comparing it with the actual constant type, but also extracting an integer value out of it and giving it a variable placeholder which I can use. So this is the all definition you have. Show. What is show in? Show in Haskell is very similar to toString in Java. The inbuilt, show the toString method to show the actual representation. And because we are dealing with the primitive types, it is well defined that how to print an integer or int in Haskell. So far so good? Okay. Okay, so let's pretty print. Okay, pretty print. Now the way I call it is this way. I say constant like 42. Okay, so it's print, right? So I can also say like constant 45. Oh, sorry. Let x is equal to constant 45, and if you it has to be this way. Okay, expression arising from the use of it. Oh, because we haven't implemented the show for this. Deriving show. Okay. So if I load the expression and say constant, yeah. Okay. So this is like deriving show is like implement. So this is a little different than Java in a sense that so define the data type, also define the basic definition of show for that constant. Okay. So in Java, you don't get to choose this. You always inherit from the parent object class. But here you have a flexibility. You may choose to derive in the sense implement the show method or not to. Okay. So that is about deriving. Okay. So if I which method? Yeah. Right. So this is like a data abstraction constructor, you can say. This is REPL, right? REPL, you can fiddle with it. Pretty print is the name of the method, yeah.
We are not writing method use. So how is this working? Is it a syntax like this?
I didn't understand your question. Could you please? You're talking about this code, right?
Yes.
Okay. Yeah.
We are not writing pretty print.
We are not writing.
We are not referring to the method. Pretty print and then constant and then 45.
So this is Haskell. This is Haskell syntax and semantics. Yeah. So there is no many ceremonies like Java here. Like you have to define what is public and that define the method symbol and all sort of stuff. Okay, and also like so for example, now since you asked, so suppose a given method accepts more than one argument, so it could be written as this, like expression. So suppose it accept two arguments of expression, okay, and returns this, okay. So whenever you look at the Haskell method, whichever is the last one, that is the output. All the rest which comes before it are all the arguments. So that is how the declaration goes. Declaration of semantic is, okay. So if we, which we did, like constant 36, so it's gonna print it. Okay, now now here we take a different step, like so if I add a new operation, it is easier. Easier in the sense I don't have to touch the existing code. Okay, I didn't have to touch the existing code but define new one, right? So how do I evaluate? Sorry, so constant 334. Oh, sorry, I didn't load it. So again, this is REPL driven development is very good, when you build a project and all. So otherwise, you save it and then, as opposed to like Tomcat starts or any other JBoss starts and then whole process and there are hierarchy of class loader. That that stuff is really really simple at the Haskell level. Okay, so we are able to now we are able to add a method in the Haskell without touching the existing code. But when it comes to add new type, right? Then we have to touch the existing thing. Okay. So what if it was in a different module which you don't have an access to? The same thing that you discussed in Java example. Okay. So that's not the thing, and then you have to define for add and also the evaluate. Okay, so what we are doing here again, pattern match. Okay, I am getting as an expression, but what is it actually? Is it the add or is it what is it? Right?
So, like all the lines are different things. Means if the input is different, then it will only execute the second line.
Exactly, yeah. Yeah, so in procedural and OOP languages, there are statements. In Haskell, there are only expressions. Okay, so it does not. I mean, you cannot mutate anything unless you port any some C extension and try to link it with the runtime and do your own thing. You cannot do it in the Haskell itself. It's strictly prohibited. Okay, so what we did, print, take the add and extract it as a L and R, which is left and right, and pretty print it because pretty print is already mentioned, right? So this is like a recursion, right? L, and so this is the plus plus is an operator for the semantics, like if you want to append the strings into it, the Haskell way of doing it. Okay, so the only thing I like you to focus on is like how the given programming languages let you extend by default. Okay, in Java it was really easy to add the new thing, right? But it wasn't so easy in a sense that you don't have to change the existing code to add a new method or add a new behavior. Here, adding a behavior is simple. Okay, so let's load it again. This is visible, right? Okay. Okay, so last time we evaluated and it is pretty print. Okay, so this time we're gonna say add oh hmm. Okay, so printing doesn't actually evaluate, but it just tells you what you're going to do, right? If I try to evaluate it, right? And the same thing again with negation, like add a new thing, so you have to kind of, you know, modify the existing code and then go on writing the thing. And okay, one thing, what if I negation, will it work now? Okay, so you understood the thing. Okay. Hmm. Okay, so we can say the same thing which we did, just the opposite. So in the constant, instead of saying constant, we can say like negation, negation 44.
Radius and there
Yeah, yeah. So in Java, we kind of had it constant passing to it. I mean, you could do it either way. Yeah. Okay. So this is the problem. Okay, which we have, and so now going back to this thing, now it would be more familiar to you. Does it ring a bell now? This statement. This statement is now fully understood, right? Okay. And we also seen this, like as we were doing in O, like in Java, you were adding new things like classes, operations like a method. Sorry, uh, and and totally opposite in the functional world. Okay, and that is how we. So this was same observation we had, right? Okay, so there are some solutions to get around it. So we'll see how that works and to what extent it works. Okay,
can same thing be done with C using type deletion?
same thing can be done with
C, asking like can the same thing be done using the C type using type def
type def.
yes.
Yeah, so in C you have a struct and you have a method to it. So whenever new type comes, you can override that method. But what you cannot have is the hierarchy of the types. I mean, you cannot say a particular struct can inherit from this struct, right? You can use it inside it, but you cannot have a hierarchy of it.
How this Haskell is doing this?
So Haskell is doing it using the ADTs, right?
Means the expression, the add expression is inheriting the constant. You use it, right?
Inheriting
Constant.
with which one?
The add expression.
No. So add is of type express. So all of these constant, add, and negation are of type expression. So if you want to say in using struct in C, I am not sure about the type def and all, but as far as I remember, the last time when I did C was 11 years ago, roughly. Okay, so you cannot have like struct a particular thing, then you define the type, and then you have on top of this, right? Okay, so let's try to solve. So one of the methods is multiple dispatch in Java. Okay, multiple dispatch, or it's called as multi methods. Okay, so visitor is one of the patterns which we can make use of. Visitor is one of the design patterns from Gang of Four. Okay, and so we'll try to do a visiting job, visiting different classes and all. So what visitor intend to do is separate the data and the operations. Okay, so let's see how far it can go and whether it does really solve a problem. So I have a visitor interface. Okay, it says visit the constant, just one single method, and there is this expression. Okay, it's gonna accept the visitor. Okay, and see uh, if any one of you or the online people who attended my previous talk on architecture, as I mentioned that most of the problems in the software are solved by another level of indirection. Okay, so this is another level of indirection. Instead of directly having it constant and expression, implementing it, we are going via a visitor interface. Okay, so what do I have here? An expression, same thing, like constant, accept the integer, but this time we will not implement all of those different operations in the class itself. We will not implement it in this pattern. Instead of these, we will have a different visitor implementation to imagine the actual implementation of that operation. Right? So what do? The constant, this thing, it gets the num, it visits it. Okay, so let's try to now add new operation. Okay, because new operation was a problem, right? So we already have a print visitor. Let's try to add evaluate visitor. Right? What is gonna be? Integer. Okay, so of course we have to implement the abstract methods. Okay, what am I gonna do here? Just simply c.num. I made it public. I mean, you can have a getter setter methods if you want. Okay, so adding new operation is simple, right? But what if I want to add new thing? So I only have a constant here. What if I like to add a new add operation, like numeric add operation? Then I have to go in the existing thing and modify it. Visit the add and then say maybe add, right? And that add I have to again define as something like an expression which will accept not integer but the expression themselves, left and right. uh, 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 okay, visit add. Okay. Now of course, because it is so repeating, the accept depending upon what to add, you can have an some default instead of interface. You can have an abstract class where the accept method is really generic and it calls depending upon that add method. Then, but depending upon visit constant and visit add, you might have to cast it, right? But in any way, you have to modify the existing code. Okay, now of course, when we added the new type, not only it caused like, I have to, so visitor was our level of indirection. I had to modify it. I also had to modify the existing print visitor and your visitor, right? Because these gonna have the definition, like how does the add behave? Sorry, how does the print visitor behave for the add operation? Okay, and how does the evaluate visitor behave for the an operation? Okay, so printing it. So how do I print it? Say add left view. How do I do that? ToString is, well, you can use toString, but you'll see. Right, and of course the same thing here, of course, just that you just have to remove this. Oops. Expression. Right, so this is like, we are changing the direction, right, in the Java itself. So in the Java itself, we are beating it up on the ground that we are making it easier to add the operation and it's difficult to add the basic data types, which is very against the natural intent of Java itself, which is the OO paradigm. Yeah, but so here you're adding is easy to add new operation, but it's difficult to add the data types. But it still doesn't solve the problem, right? Okay, any questions here? So let's try to print it. Uh, is it compiling well? Evaluate, okay. So when I evaluate a simple constant, it's gonna be 4. When I add, so add is this 4 minus 6, right? It's gonna be minus 2, and of course the printer version of it, right? Okay, so okay, let's go back to Haskell. Now what I'm going to show is little mine, just a minute, where is it, extension. So this is how you try to do it in Haskell. Okay. So what we did earlier in Haskell was we had like segregated the thing, like the expression, the add and negation and all. Okay, and it was difficult to add a new type and the yeah operation. Yeah, this is Haskell. Yeah. Okay. Now what we are trying to do here is having their own definition, the separate definition of data types, and their separate definition of their the implementation. Okay, so this is one step forward in the Haskell land. Okay, where maybe I can show you a simple example. It might help. Okay, so I like to introduce another feature of Haskell, which is very, at least in this context, is very relative to Java interfaces. Okay, so the classes in Haskell are like interfaces. So it has a totally different notion of class. Okay, so what I'm telling is, okay, define a class having the name shape, and this is like my what do you say, generic operator. So we have similarly used t here, right? In Java example, we have used t. In the visitor, we have used t, right? And it was at the method level, but you can also use it, for example, at this level, right? T, and then you can use it here and stuff like that. Okay, so it's quite similar to that. So the shape is that T. Okay, and so I'm defining a very generic method that it kind of accepts shape and always returns a string. It's a position. It accepts the shape of type, but it always returns a vector 3D. Vector 3D is nothing but a custom type which I have defined, which stands for a tuple of 3 doubles. Okay. Okay. Now so in this case we have defined the previous one. We have just defined like expression, and all this stuff. This is another way of defining in Haskell, where you mention like sphere is a data type. This is the constructor object, and it has some type. So as you said, like C struct it's very similar to C struct. Just that it's actually compiled to C struct. Okay, so this is the name and this is the type, as simple as that. Just a little syntax is different, like double colon and okay, and we have another type like prism. Okay, now I have defined that. So what I said was Haskell separates the data definition from the method definition, the actual behavior definition. Okay, so we have done the data definition. Here we are doing is method definition. Okay, I like to define this shape, all of this set of behaviors, like what is going to be the name, what is going to be the position for sphere, for prism, right? And we did not had any constraint on it. It could be anything, but the only constraint is it should return a string and vector 3D. Those methods. These are declared. So this is pure declaration, 100% abstraction, just like interface, and this is the implementation of it. Okay. So what I'm saying here, I have to override, of course, the name and the position. Okay. So where does this sphere name comes from? Right. So because we have written the sphere and it is also a property of sphere name, it is implicit that you can actually access sphere name directly here. You don't have to do very much ceremony that you define it and declare it as a variable, then say dot sphere name. You can just directly access it. Same goes with the prism. Okay. Okay. And so this example I think we have already covered, like deriving the show and all, because show is like a two-string method. So I have declared a new type, but I have not defined how that kind of two-string like a method would work for it. So I have to define show differently, that if it is the prism and this is the show, okay, and these are the different this is again pattern matching. I am extracting all of those things, and this pattern matching helps because why? It helps Haskell achieve that there are no assignments in the language. Okay, at least they are hidden from the actual, the end user. I mean, of course, at the runtime and all, they will be doing some, IO and setting, but you are not supposed to do it as a Haskell user. We will provide you that feature. Just ask for pattern matching. Okay, so the same thing which we have here, I'm just calling a show on it. Okay, when I call a show on it, I'm calling a show on what? The actual types. So because these are predefined types, primitive types, show is already defined for them. Okay, so I'm just using show as a decorator for each and every one to build a show on the custom data type which I have defined. Was so good? Okay, so let's load it. Uh, Inherit. Okay, so let's try to say what's the name of a particular prism type, right? Which has no, because this is the record structure, we have to have like prism name. Okay, define like this: prism name, suppose prism 1 2 whatever 1 2 3, and the other one is prism position. Prism position maybe whatever 20. Sorry, it's a vector, right? Vector 3D it is, right? So I will define maybe 10, 20, 30, right? And say prism dimension is I don't know, whatever. Prism dimensions. Okay, prism 1 2 3. Okay, so when I ask for a name, it will give me a name, of course. Uh, okay, if I like to show all of that, it will give me this. Okay, because I have defined the show method on it. It's a pain. No, it doesn't work in terminal. The GHCR REPL. So this is actually MacOS terminal, which is spawned via the IntelliJ IDEA. I don't know, position. What is position? Right? It's saying dot. I mean, it is doing automatic coercing. Even if you apply integer, not dot zero, because the actual is double. Let's go ahead and sing it. Okay. Now back to this. Okay. So we have defined a constant as a different, add as a different. Okay. And then we have this class expression x, okay, the instance of it for the given constant. And look at this is like a little overwhelming. So what I'm saying is here, define the instance, okay, for the add, where left and right are also the expression, okay. So here I'm not defining the type anywhere. Here I'm defining the type. It's a constant, and a constant should be int. But I'm not defining any type. So as Haskell also supports type inference. So it will look out for the existing, okay, if you do not define it, it's okay, but it will check in the given module that where have you actually used it. Okay, and it will take that type automatically. So it is implicit that add is actually, the left and right are actually the type expression here. You don't have to say it explicitly here. Okay. And now, if you want to add a new type, so suppose, initially there is only a constant. Let's see this way. There is only, we have not defined this thing, we have not defined evaluators, and we neither have defined this instance. Okay. So just let load the extension. Okay. Now, what do we have here? We can. Oh, by the way, as I said, like it has a clear demarcation between the pure and impure stuff. So printing the string on terminal is impure. So you have to mention it's a IO operation. So you cannot say void. Like system.print.ls, like void. No. You have to say that it's an IO operation. So everything has a type, basically. So let's say pretty print, again the same constant. Okay. Pretty print works. And also, so this is the put str. Yeah. So as I said, like in Haskell, there are only expressions. There are no statements. But sometimes you need statements. Okay. So that is why we have a do here. Do is a kind of monad. So from Haskell point of view, even if you are doing in a sequence, that's an impure thing. Okay. So this is the monad which lets you do the impure thing. This is my first statement. This is my second. Sorry? Yeah, separate by semicolon, or you can do like this. Then you don't have to mention this. Okay. And put str is like our system println. It's about, okay. Okay, so if I like to add a new type, right? I don't have to compile anything. I am just adding it, right? I added the type. I have to add new operations to it. Add left. Okay, and by the way, you can have this instance of any of this expression in any of the module. I'm just for a simplicity purpose, I'm I am writing it in a same extension module, what is like similar to a package, okay? But you can have it. So let's try to load it and say now I like to evaluate, right? Evaluate what? Constant v3, right? Now if I like to evaluate add of, addition of, right, constant of 78 review, right? So that is how you manage with these complexities. So some of like languages you may not be able to achieve full of them, but in
What is the area of where SQL is used?
it's a very general purpose language. So for example, Facebook uses it for online spamming engine. Okay, so you go, so suppose you're a Facebook user, you kind of put some comment into some groups. There are groups, right? Okay, and many of there are many members in the group, and you just put one comment. So the moment you put a comment, there is a real-time spamming engine. So it's like, for example, I put the comment, and I put the comment about say Haskell or any other thing which I am not related to. So internally, Facebook will analyze data that, I mean, they have all the data like from WhatsApp and Facebook and all other stuff. They have like machine learning. He does not have an interest in Haskell. He does not have an interest in or any other X topic which he like uh, to do comment on that forum or on that group. Then how is he doing it? Okay, and it executes in real time, and within a second it will execute all of those rules depending upon the very big data set they have, and only if those rules match the submission of that comment would happen, otherwise not. Okay, and many of people are using for web programming. You can also build a desktop application into it using for big data you can also use it.
So this is fast actually.
It is faster than other functional languages. Okay, so the way it have is like Haskell. So when you write the whole code, it compiles into a language which is called as C minus minus. There is C, there is a C plus plus, and there is C minus minus, which is a subset of C language. Okay, and then after it gets compiled, they run very many optimizations. Okay, so even if you are doing something like so I don't have an example here, but so, so Haskell is by default lazy. Okay, so suppose if you want to type something like, I don't know, 1 to suppose 20. Okay, and so there are some of the things like let me give you an example of say what could be the good example, like show 1 to 20. Okay, so map is a function, okay, which will call show function on each and every input of this array. Okay, so it's showing, so it's like it calling a two-string function on each and every part of that. Okay, so 1 to 20 is the array, it is calling it. Now what if I like to do it lazily, as in when I do it? Okay, so suppose I have two functions, like say let um, uh, say x is equal to 1 to 20. Why is not, would I be num infer type? Oh, okay. Okay, let's. No, I'm doing it wrong. Okay. Let's x is equal to this x, and x we already have it. Now let's define y, which is nothing but a cycle of say 5. Come on, is it cycle or how is it? Cycle, no, just a minute. What if I say only cycle of 5? The not really checking info type. Just a minute. So what cycle does is it continuously, when the moment you access it, it will continuously. It's a lazy list of 55555, and when you try to zip it, okay, so there is a zip function. Like for example, if you like to zip x and another thing which is like 23 to suppose 800. Oh, come on. Huh? Just a minute. Double? Oh yeah, keep writing it. I don't know. Oh yes. So there is a zip function which takes the two list and you know look at the index of it and make a tuple of it. Okay, but it will go until the lowest of this. The lowest is x because x gonna have 20 elements. The second one has gonna have element up to 800, but it stopped at 42. 20 and 42 was the last one. Okay, the similar thing is, so there are many lazy operations in Haskell which you want to do. So if you want to try to implement your own map or filter, you only do by pattern matching and applying the same thing again and again and again. Okay, and but it is so much optimized at the lower level that you will not see any differences. Like for example, in a linked list, addition or retrieval of element is simpler, right? But not, sorry? Does anybody have a question here? Okay. Also, I read that Haskell methods are not evaluated unless they are used. It is right. It is not evaluated, of course, yeah. They are not evaluated unless they are used, yep. No, they are compiled. They are compiled. They are just not evaluated, but yeah, that's if you do not call it, they are not evaluated. I think there is a lazy, there is already a lazy. So if I want, is it, no, lazy is a different keyword. I'll show you the example. Lazy variable. I have just fiddled with it. I did not, of course, write any production version in Haskell. No, it's not. Anyway, So by default, yeah. So one of the things is like, in the expression, whenever you say let x this be thing in this, and return that, because now since we are doing whole thing in the terminal, we have to say the let, but we don't have to say the let when you actually write the, this thing. And the only scenario where you use the let in actual programming is, so this is a very common thing, like, you, instead of, if you are doing multiple things, like, suppose I am doing here a thing called as, say, I don't know, let's do it in the main. Maybe here. So there is some test, okay, and it accepts some integer value, okay, and let's say, or maybe simple add operation, okay. Okay, so the way we are going to do here is, a and b and a plus b, right? So I can do, so if I like to extend it little bit further and say like let x is equal to in we have to think of any complex operation here, like add plus, suppose a square and b square. Let's say square, okay, let's say square xb. Just very simple, I mean, for simple example it may not be that useful. Let x be a in x is equal to x. So suppose say addition, okay, of square addition of square of nums, okay. Okay, so what I accept here is a list of int, right? So a is a list of int, okay. So first I have to create a square of it and then sum of it, right? So how do I do that? So let's say it's very hard to imagine addition of, so a is the, what is the reduce approach? Oh, I mean, it should be solved by another, okay, means, but that x is equal to a in, say, sum. Do we have a sum of square of, that should be map of square return maybe 2 of the actual value x. Okay, I don't know what's gonna that print. It's been load it. Come on, load the inhale. Okay, now have the addition of. I don't know what's gonna print it. So it's not doing square. It's doing like you know. Uh, hmm? Yeah, it's multiplying by 2, and then it's not actually the square. But that is how you use it, like in. Okay, so if you have multiple, like let x be this, let y be this, and then you combine into actual expression, and then you have it, stuff like that. So it's just like a lexical scoping, nothing. Like you can have any expression here. X is equal to some expression, and then you are passing, computing it, and then after you say in, you are combining those expressions. And only where you use it X is it is reusable, or it makes sense because sometimes what happens is because it doesn't have a statement Haskell, you end up having chains of expressions. Like we have seen these chains of expression, like so say name of prism, or we maybe here we had a pretty print and then add and then constant and this. So instead of that, we can say that let this constant be this and that in this is the actual expression. You have evaluated this, but unless this in expression get evaluated, all the expression in the let will not get evaluated. So by that sense, it is lazy. Okay, now one last thing is, okay, do we have questions? You can Haskell be used for IoT development? So the runtime of the Haskell is pretty heavy. Okay, uh, I don't think it could be. I mean, of course, across all the runtimes, like Java and all, they actually even JavaScript they actually come up with the stripped down runtime, which works, but I don't think it's a good language for a IoT development. IoT is Internet of Things devices, the small devices like this one, which is on that table, the Arduino device. Okay, so it has very less RAM memory, like in terms of like 16K or 8K RAM memory. Okay, so that is not, I think, efficient to just load the Haskell runtime GSUI. But there is an operating system which is written in Haskell, so that's possible. Okay, we also have some. What is val time compute 5 if method evaluated in the condition is here compute 5 is evaluated if the if condition is yes, that's correct. Yeah, that's correct, Sarang. But it looks quite nice, like so clear. Once you understand it, of course, this might be the first time, but and because it is very pure and every function has to return something, there are very good tools around it, like for example quick check, which is used for automated generative testing. So even if you do not write the test cases, it will automatically help you generate the test cases by just looking at the types, right? Especially when the IO is there and monads are there. Um, and that is how it will tell you that uh, this function might fail if you provide certain kind of input. Like for example, some of the function accepts string. So the quick check library will generate many of the different combination, like with characters, with weird characters, and try to test that if it's gonna run or not. Instead of, I mean, you cannot think of every other situation. You are biased when you are typing your program, right? You are biased. That is why we often have a different testing team to do from their angle, like black box testing. Have they taken care of it not? So it does it very automatically. Okay, so the one last thing which is we like to discuss is the open class. Multi-methods and multi-dispatch is the same thing, which we have seen in the visitor, but it doesn't really help as far as Java goes. But there are multi-methods in, for example, closure and closure script, which I am going to have a talk on 22nd April. Not now, because that's gonna be little out of context. Because so multi-method and multi-dispatch is about. Uh, so for example, method overloading, right? You add two integers, add two floats, is only in that context. Okay, multiple dispatch is, it also matters what kind of object you are passing to. Just like we did in visitor. If you are passing the add kind of object, it will call that kind of evaluate method. If you only pass constant, it will call the evaluate method of that evaluate visitor. So it's both way. Huh? What is the? According to the reference of the object, yeah. The actual object. Yeah. So open classes are there in Ruby, there are in JavaScript and Python, something they also called as uh, monkey patching. Okay, so that is kind of really weird way, is like you already have your project defined, right? You already have your library, then you write a code to patch the existing functions into it. Okay, so for example, there is a G event library in Python. So Python is like synchronous, like it does it is all of the operations are blocking. Whether you connect to a different database like Postgres or file system, all the operations are blocking by default, just like Java. By default, it's blocking, it's not non-blocking. So if you use G event, okay, it will, whenever IO happens, it will turn that call into a coroutines, into non-blocking thing. And but that way it is a very hacky idea, but it's a very useful idea. That's turn the whole code synchronous code by not actually touching the code, but actually patching it. Okay, so the one example which I could give you in JavaScript is simple this. So this is like a, so what we discussed, like the data types and the operations. You should be both able to add without adding, modifying the existing code. Suppose I add this, add. So the way to now this is little old way of achieving it. If you look at the ES6 syntax, there is a class, but if you follow this prototypal inheritance in JavaScript, you should be able to achieve, solution to this problem. So add is an actual type. So everything is a function. So this is the type, like E1, E2, okay, and you should add a value of it. Then you add a new operation. So whether you add a new operation like add, sub, and num, these are different from whether you add a new value to it or function to it, method to it. And similarly, you can add a toString. You can override the toString for it. That is why I like dynamic languages.
So this is example of what?
JavaScript.
So means for example of
Expression problem. But it's kind of tricky because what he said was not compilation. Compilation happens only for the statically typed languages. There is no compilation here.
this interpreted language.
Yeah, it's a dynamically and a purely interpreted language. But well, you can get a solution for that.
What is the open class?
Open. This is the open class. Open class is a class which is open to accept any new methods at runtime. So if someone is coming from only from Java background, it's gonna be very daunting. How it could happen? Or C sharp background, or Haskell background even. Okay, but so it is also one of the say like meta programming techniques. Okay, so for example in Ruby and of course in the Python, everything in object. Even in Python, everything in object. Everything is a dictionary, and even dictionary is an object. Okay, so you can manipulate at the runtime. So everything is open, but with great features comes great responsibilities.
There is no open feature in Java.
Huh?
There is no open class feature in Java.
No. I mean, there are something like, for example, Spring, older version of Spring, they really make heavy use of the bytecode manipulation library. I forgot the name. That's a very famous library, right? Which manipulates the code for AOP and all that thing. So when you have the annotations like AOP, I'm gonna have an interceptor here and that thing. So it does the bytecode manipulation, but it is not at very runtime. I mean, it's not available to you as a user, or at least not in a very simpler way. You can do that, but then you again have to write the different code for that. Again, that is static and all. It's like so that might bytecode manipulation is like one step ahead than using reflection programming. Okay. Um, yeah, I think that's it. This is the reference where he actually wrote the mail. Philip Bottler and circulated in internal mail system. Thank you.
Actually, I have one question.
Okay.
You told earlier that Haskell is used for data programming, right? For data. So there are so many languages like R, Python, they usually provide libraries. Like if I suppose linear regression or any kind of like logistic regression. So there are equivalent libraries for R and Python. So is there any plugins or something like that in Haskell?
Right. So the question was, are there any statistical or data computation libraries for Haskell? The answer is yes. There are many of them, and there are very good of them. So if you, so it's called Google, the brother of Google. Okay. So yeah. So this I should have mentioned it before. In Google, you can. So this search is. So suppose, as I seen, like if I type for map, it will say map. But you can also type for you can search for a signature, and this is really powerful.
So there must be a way to integrate Haskell from Java, like we do in R, like R server.
Yeah. Just a minute. Your question was the statistical libraries in Haskell, right? I statistics library. Yeah, yeah. Statistic, there is a different package here. Statics, there are many of them like geometric, and so these are the internal modules for it. There are many of it, and 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 one thing which I like to highlight again is like the GHC runtime of Haskell is so since I mentioned the monad, the IO word, right? This IO thing. If I go back to this IO, okay. So whenever we are doing the pretty print here, it's a synchronous operation. You have to wait, but you choose not to wait by providing the alternate IO um, IO implementation of this. Okay, because everything is IO, okay, and it is a monad. You can swap it out with your own definition, which help you do the asynchronous part. Like for example, in JavaScript and all, you have to do a callbacks. Now there is a yield parameter in ES6 which makes life easy. But if you want to do it in Haskell, only change you have to do is just change the type to a different type and implement it in different module so that it does not do a synchronous application, which is really flexible, really flexible. So so for example, JVM only supports it doesn't support the continuation. Okay, I mean there are some NIOs and all, but not all of the libraries. I mean they are getting on the way, but major of the, like for example RDBMS or JDBC extension is a synchronous. You do not have a reactive way of doing it, right? You cannot say I am waiting for output. The thread just blocks. That is not the case with Haskell runtime. It also supports multiple, it can make use of all the cores of your system, one single process, plus it can also have green threads. So these are called as green threads. The G event example I have given you for Python. And so Haskell has an inbuilt support for the runtime for the green threads. And there are many green threads, like that Facebook example which I gave you. It spawns thousands of green threads which act as a small processes in the Haskell runtime system. So the abstraction, so for programs like a different threads, but those are not actual threads. Those are like green threads as seen by or managed by runtime. And of course, at the bottom of that, there are actual OS thread, which in turn manage those life cycle. So, I mean, this is the most well thought language in the universe, Haskell. Every other thing, I mean, and all of these who designed it, most of them are mathematician and come from mathematician background. They well understood what was the problem, how is not to be in, compared to other languages. And because it is not so easy to do a printing and all, it is not a widely adopted language, but it is. Uh, I mean, we are seeing more adoption after the actual enlightenment of functional programming. So, if you want to learn, this is the way to learn functional programming. If you learn Haskell, then every other programming language is like, oh my god, it's like very ugly.
But why?
Why?
If you say I need to learn Haskell,
Uh-huh.
means
To learn functional programming.
yes, learn functional programming.
Yeah.
What I say, means if I say give an example of Python,
Uh-huh.
it is good for data manipulation and statistics.
Hmm.
So what is Haskell is good for? Best for?
So that's what I'm saying. Haskell. So if you go to this Google package, you will find every other package for connecting to MongoDB, for connecting to RDBMS, for connecting to. There is a web framework called Yesod in Haskell. Okay, so it's a web framework for Haskell. Oops, I'm not gonna do that. I don't know. Anyway,
So
uh,
why Haskell is not used in production? I have not heard of that method.
yeah, because it is too pure, right? And many people don't like pure.
And
I
what
mean,
is the scenario that is different when using a function programming or Haskell? Right now, any projects we get in do it in Java or any other Python.
so the question is, so that is what we discussed, right? Uh, so these are like, if you look at the natural modeling intent, O and functional are complementing to each other in a way, right? Pure O and pure functional, right? The aspects of it, they are complementing to each other. If you are using it O, just because Sun Macro System and all other guys have marketed it so well from late 90s, and we are using for every other application, why can't we use functional programming? Even I would say that because so, okay, so in real world you will see the more set of fixed set sorry the more increase in, so as your project uh, you know uh, advances and has more and more requirements, there are more things to consider, and there are more operations also to consider, right? But in my experience, at least, if I look at the different projects which I have done in last 10 years, there are, I mean, if you try to make a balance, like how many new things I have added and how many new features I have added on the existing thing, I have added more operations. Okay, so in real world, it's like both. You also have to deal with new operations and the new types also. But what should be the default language you should use for? If that is the question, then functional programming, because you add more operations to it. O become popular because in 90s and a decade after that, everything was about GUI programming and these and that, and it is very simple to say that have the most blunder thing they have done is like you can map the real world into the classes. How could you map it? Like, suppose there is a restaurant. Okay, restaurant, you have a dining tables, you have a different waiters, you have a different this thing. From real world sense, when you try to visualize and create that kind of jungle of objects, okay, what you're trying to say is I am creating the whole world, like that restaurant, and then you try to inject into restaurant the different dining tables. So the dining restaurant is made of dining tables, then waiters. What it's not even matching it. And the most important thing which functional programming uh, addresses, it does not messes with the time. All the values are immutable. Like, for example, Narendra Modi is the Prime Minister of India today. That may not be true after 20 years, maybe 10 years, maybe 4 years. Okay, so each and every time, okay, there is all in procedure and OOP languages, there is always a mutation. Functional programming says no, all of these are facts and they should be associated with timestamps. It was still a fact that Jawaharlal Nehru was a Prime Minister of India. It's still a fact that other presidents, the other persons in the history was president. Sorry, the Prime Minister, not the. So like that way, and even there are functional databases which does not allow you to do update operation, only insert or query. There is no update or delete. Okay, so you be clear on your intent, what you want. Do you like to query the current state of it? You tell me what is the timestamp. If you want a timestamp, if you like to know the state of the database at the given timestamp, give me the timestamp as now. What is the date now? If you like to reproduce the whole thing, give me the timestamp like a week back, or a month back, or a year back. Okay, and if you follow this, you don't have to have other sort of problems like O world, pure O world is all about incidental complexities. Okay, just because you are mutating it and you are not logging it, there comes different products like, I like to do a audit logging, I like to do this thing, that thing. If you only insert new things and keep all of them, you have all the data you need. You just have to query in a particular way to get that information. And one of so Datomic is one of the database which is going that way. It is built on top of JVM using Clojure language.
Another
Okay.
question, like you said, like the Java,
Yeah.
the input of the programming language,
Hmm.
like when a restaurant can be ramped in the book. So how is this possible in the functional language? If you say
How is it possible to?
in the functional language, like in the restaurant, we have restaurant, we have tables, we have these all the things are read in the classes.
Right. So
And
okay.
how
So
is
the
this
question is, how would you model that restaurant thing? Okay,
in the functional
in
language?
the functional language. So you look at the functional behaviors, because what function good at? The operations. What is the operation? You focus on the operations. What are the different operations you can make in the restaurant? You come to a restaurant, sit on the table, make an order, pass that order to a chef, get it back, serve that order. Okay, so you see, you already talking in terms of already operation, what that matters. Now you can have that different operations. Now in Haskell terms, now there are two things: dynamically functional language and statically typed language. In statically typed languages, you can derive, like, suppose there is a, so first you focus on operations, get a list of it, then you think of type. Okay, so what is the type for making an order? It will have, okay, even before that you have to have a menu. Okay, so there going to be a static menu from which we have to choose from. Okay, so that could be a simple data, which, so the order you do is simply a list of things. When I say things, they are not at all now associated with behaviors. We are explicitly, by defining a different operations, we are associating with the behaviors. So list of things. I want a particular, I don't know, pasta, a garlic bread, and a mojito. Okay, so these are different list of things. Depending upon how complex you want to make it and how deep you want to make it, the restaurant problem, you can have a set of things. So let's not say set of things. Let's say set of that data type. Okay, so just a data type, not things. Because when I see things, it's like a O thing, and then type and also behavior comes into a picture. That data, then you pass it. So O always need a manager. If someone is like, someone is managing this thing. Okay, in functional programming, it's like just an operation. Just do it. Okay, so in O, like restaurant, so how do you simulate the behavior that waiter is coming and taking an order? You need some kind of different management interface which talks to the already modeled O interface to make it happen. And there's very really good quote about it. What I wanted was banana. What I got is banana. What I got is gorilla holding a banana and entire jungle with it.
Yeah, if I say really, to be frank,
Uh,
I'm not exactly in favor of that.
hmm.
Whatever you are saying, this is good if this you are in a limited thing. But according to my example, my experience, like
Can you give me an
like
example? I'll give you a simpler example of that alternative functional programming. Hmm.
it's not about example. Like
Uh,
what I say, like there is C language, that is
okay.
also functional language. Like
It's
so,
not a functional language. Well, functional language, well, you can pass the function pointer here and there and you can have it, but functional language has many other things like, the immutability and other stuff. Like, so it's not totally, there are some functional aspects to it, but it's not fully functional language.
okay. So
Yeah.
what I need to say,
Hmm.
like according to my experience,
Hmm.
you can find some problem in a box like something. Like if I say food,
Right.
making food and
Hmm.
everything, this is in a wrapper here. So according to like having complexities and later changing it to it and debugging it,
Hmm.
then it object programming needs to help us to later on manage it efficiently.
So
Like
that
in
is the
functional programming,
right.
like everything is in the same thing.
Yeah.
No clusters like
So 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 since we are getting into debate of OO and functional modeling, two things I like to discuss. Like I have a experience of like 5 to 6 years only OO thing, and rest of that functional. And the thing which I have learned is before getting into the debate, you kind of solve those actual problems by two different languages, write the test cases, and see the effect. This only will tell you the benefit of that. Even if you're not convinced, then you know, then there are some things you are doing it wrong. Like first thing is you are doing so the one thing which I think is is encapsulation is a overrated thing, really overrated thing. It's the only incidental complexity which comes into your picture. Like in because in functional language the data manipulation is so local, like you just have to so even from a, so, from a person perspective which is not so technical like product owner or something, what the system what how they see the system as a black box which has some input and goes the output, right? It is really able to model that system in a functional languages. I mean, of course, from my experience, than in object oriented. Like from each and everything, uh, it's so damn complex. Is like and third thing which I like to mention is, as I said, these are complementing to each other, pure O and pure functional. Sometimes you might need O for closure, closure in the sense S. So, as they say, objects are poor man's closure, okay, and closures are poor man's object. Okay, depending upon whether you are using O and the functional. If you are using object-oriented programming, what you are doing is, so in this example, right, what you are actually doing here, you are creating a closure over it, this integer and this expression left, okay, so that you can use it in, sorry, not this one, this, this one it is more clearer. Okay, so you have encapsulated something into it, and then you have, pin this method. For this simple example, you may not see the complexity is like very simple, but as in when you model the system, okay, there are more things because OO programmer only like things, materialistic things for actual modeling, things for managing them, things for maintaining them, things for maintaining the different maintainers of it. There are things. Okay, even if you take a simple example of Spring web application, you must have worked in Spring, right? You are from which background? Android. Okay. Have you used any IOC container framework in inversion of control? Inversion of if you do not know inversion of control, you haven't seen the object-oriented world. Then
version of control.
yeah, And so the data manipulation. So my favorite is not statically functional programming. My favorite is dynamically functional programming. Of course, that is not to say that that's the only thing good, but it kind of fits with my mind, and the local operation which you can do with it is really powerful. If you just dumb the types, but by the way, we are getting little out of the context from the original thing, but since you asked, like, if you just dumb the notion of the types and replace it with more dynamic thing like hash maps, like for example, we had this thing, right? Um, so if you just replace this record type of thing or struct type of thing with simple hash maps, so these becomes the key. This becomes the actual values. Okay. And since there is an advancement of in software industry, like there nobody was doing like TDD very seriously a decade ago, but that's not the case.
It's a practice.
Yeah, it's a practice. Now, if you already doing this practice and if you are testing your code in each and every scenario, then the I think, I mean, at least I think, and I have experienced that gap between the objective gap between the statically type and dynamically type is like a very reduced to a thin line, right? Because even if you're shipping your product, if you're not testing it, right, then everything will go wrong. So if you're testing it, you're also testing the value of it. And if you're the manipulation you are doing, it's very local, and you're only focusing on the operations, which is like a feature-driven development. So most of the guys talk about feature-driven development from the product owner or uh, from those point of view, non-developer point of view. Okay, but that is not to say that objects are not. So sometime in functional programming languages, even in JavaScript, it is needed because closures are needed, but but use them very wisely wherever they are needed. Okay, I will talk more upon that. Actually, talked a little bit on that in the previous session of JavaScript, and I'll talk more about that uh, in the next session, which is going to be on closure script and how it handles the whole sort of scenarios. But yes, but my point was default should be functional and use the closures and object as an enabler, not as the basic of everything. Okay. Any more questions from online audience? Oh my God, my throat is. Okay. Okay. Thank you, guys. Thank you very much.